We will be factoring trinomials when a is not 1. So we're factoring a trinomial here, specifically a quadratic. We're going to factor it. We're also going to check our work. Now, the method I'm going to use in this, there's a lot of different methods for tackling these types of problems. I'm going to do something called the box method. I found the most success with that, so that's what I'm going to be focusing on. So the first thing we always want to do with these problems is we always want to check for a GCF and see if a GCF is present, because sometimes when you can get rid of that, the problem will make itself a lot easier. So the smallest number here is a 2. I can't take 3 divided by 2. I can't even take 5 divided by 2. So there is no GCF present. So again, I'm going to be doing the box method. Here's how it's going to work, very similar to the processes I've done in my earlier factoring videos. We're going to start with this back number, the 5. I don't really care about the negative right now, just the 5. And what I want to know is I want to make a list of all the numbers that multiply to 5. Well, in this example, it's pretty simple. Only 1 times 5 will get you 5. But since there's now a number in front of the x squared, and that's the new piece, we're going to have to do this for that as well. I need to list out all the pairs of numbers that multiply to 3. So that's just going to be 1 and 3. Now here's what we're going to do with the box method. So as it's called the box method, you need a box. Consider this the front and this the back. These are the front of my box, the front being to the left, the back being over here. So front numbers will stay in the front, back numbers will stay in the back. Now, in later problems, you might have several lists of numbers, several pairs of numbers here. So you might have to mix and match, try different pairs like this pair and the third pair over here, or this pair and the first pair. So you might have to mess around with a little bit, so get used to that, and I'll show that more in later videos. But for this one, I only have one option for my front, which is going to be 1 and 3. I only have one option for pairs in the back, which is 1 and 5. Now here's how the box works. So you have to check 2 different ways with each box. You're going to try and multiply straight across, meaning the top left times the top right, bottom left times the bottom right. Or, so that's multiplying straight across, or we're going to do a crisscross. Okay, so I'll show you what that means in action. So I like to draw in these. So I'm going to do 1 times 1, which equals 1. 3 times 5, which is 15. Now I've looked at, and we've kind of used the front, we've kind of used the back. The one number we haven't used is the middle, this -2. So what I'm looking for when I'm using these numbers is I'm looking to see, can I use 1 and 15 using either positives or negatives involved there? I could change the sign if I want to make -2. So the goal is to try and take these numbers and make -2. Well, 1 and 15, no, not really. No matter how you attach negatives there, you're not going to get -2. They're just simply too far apart. So if multiplying straight across didn't work, let's try doing a crisscross. So I'm still using 1, 3 in the front, 1, 5 in the back, but this time we're going to crisscross. So 3 times 1 is 3. 1 times 5 is 5. So I got to think to myself, is there a way I can use 3 and 5 to make -2? Which hopefully you're starting to get a number sense where you realize, oh, if I have +3 and a -5, so I added a negative there. Now here's the key thing. If I add a negative number to this, I have to add the negative over here. Just for argument's sake, if I would have added a negative up here, I'd have to add a negative to the 1 over there. But 3 and -5 should give us -2, which it does. You can test on a calculator really quick and do 3 minus 5, you get -2. So what I have inside my box is actually my answers. Now the key thing is remembering multiplying straight across and crisscross. That whichever I do to get my answer, the actual answer I'm going to write down is the opposite. So the pairs that are going to go together, so that's why knowing multiply straight across, crisscross is pretty important. The pair that's going to go together is this 3 and the 5, that's straight across, and the 1 and the 1. Now here's how that's going to look. When we're factoring here, remember we get 2 sets of parentheses, and you usually have your x, because that's the variable we're using, x in the front, so x in the front. And it works the same way. I need my 3 out front, so I'm going to have a 3x And then I need a minus 5 in the back. And then in my other parentheses, my other pair, notice how I'm using red and blue there, trying to help you out there, should have a 1 in the front, and that is a positive 1 in the back. Now, you might not be convinced that it works, but we are going to distribute there. 3x times 1x is 3x squared. 3x times 1 is 3x. Negative 5 times 1x is negative 5x. And negative 5 times 1 is negative 5. So when you combine like terms there, we get 3x squared minus 2x and minus 5. And now if you check and you did everything right here, this is the exact same, there's kind of a glare there, exact same as my original problem. Therefore, I know my answer here is correct. So I'm going to write this without all those writing over it. 3x minus 5 and 1x plus 1. That is my answer. And that is factoring trinomials when a is not 1 using the box method.